Hello there, Gregory Carlson here with the Calculus Building. Let's pause for a second and talk about derivative notation. If I have a function, say f of x, then you can think of the derivative as being like an operation that we can perform on that function. And one way of writing that is writing d over dx. And it's not really a fraction, it's an operation. And so we're not going to cancel the d's or anything like that. We're applying this derivative operation on the function, and that in turn gives us a new function, f prime of x. And so by now we're hopefully familiar with this notation. This function right here is a derivative function. So we do the derivative operator, apply that to a function, which then creates a derivative function. That's kind of Newton's notation. There's also another notation that we should be aware of called Leibniz's notation. And so if I say I have y is equal to some function of x, okay, and we take the derivative, then the way you represent that is with dy over dx. And so that's a derivative function. And that's kind of nice because this dy dx, remember, that kind of means the change in y divided by the change in x. And so since derivative is slope, it makes sense that we would have dy dx. So you'll see me use both kinds of notation, the f of x, f prime of x, as well as the y dy dx notation. And at different times, they're useful for different things. And so, but that's the basic notation. So let's actually start going through some derivative rules, starting with the constant multiple rule.